made possible only by the development of high-speed data processing. One of the largest of these systems is the Air Defense Command's Continental Defense Network of surveillance, detection, and destruction, which must be trained and exercised in peacetime. A natural consequence of the increased emphasis being placed on large-scale systems is that groups of people are drawn together to attend to the professional requirements of such systems. One of the largest groups of system specialists is at System Development Corporation, Santa Monica, California, with eastern facilities at Lexington, Massachusetts, Paramus, New Jersey, and Falls Church, Virginia. In this corporation devoted to the public welfare and security are employed over 3,000 people of diversified skills and talents in the development of large military and civilian systems. The major task is to extend and augment human judgment, human imagination, and human intuition by means of high-speed electronic digital computers. An interdisciplinary team approach is followed in attacking system problems. There is close interaction among mathematicians, training specialists, computer programmers, engineers, and other system specialists. Although the corporation is not engaged in the manufacture of equipment, engineering support utilizing precision equipment develops prototype models of specialized electronic devices. Let us see how a production team goes about the business of producing system materials. The particular example we have chosen is the SAGE system training program of the Air Defense Command. It is vital that this air defense network operate effectively in any future wartime situation. However, short of real war, adequate training of these crews against actual aircraft and missiles would be enormously difficult and prohibitively expensive. The answer to this problem is the simulation of enemy air attacks in a regular schedule, providing training which is realistic, controllable, and economical. In order to produce a system to train a system, a production model or scheme must first be devised. This requires the skills of system analysts, human factors specialists, mathematicians, and computer programmers who evaluate each step of the proposed production model.
I believe we can program them all right. I think the time and effort expended in programming would be purely dependent upon the length and complexity and the number, of course, of these algorithms you mentioned.
Once the model has been built and the programs have been written, diagnostic test problems are constructed to check out the operation of the programs prior to full-scale production, using hypothetical but realistic data. Constructing and testing the production model must be completed before the making of training exercises.
That's the wrong room. That's coming into Washington.
Okay, right.
That's right.
Okay, the time at the turn.
In addition, training a large system requires in advance a complete picture of the environment in which it is to operate. Researchers must obtain exact specifications on a host of environmental factors, which for the SAGE system training program includes such information as coverage of radar stations, air defense boundaries, airways with location identifiers, missile and fighter interceptor bases, and the prevailing weather condition in the area. A trained meteorologist gathers weather information extending back for a period of years for each area to be trained. An understanding of such weather situations is an important element in system training program exercises. When the exercise is run by Air Force crews, the real weather prevailing at the time will influence the defensive tactics employed. This meticulous, detailed research is carried out for all factors necessary to provide a rich fund of pertinent background information, such as radar and boundaries.
22 degrees even.
All right.
50 degrees, 10 minutes. 128 degrees even. From there to 48 degrees, 30 minutes, 125 degrees even. From there to 46 degrees, 15 minutes, 124 degrees, 30 minutes.
Specialists in operational procedures in related military defense systems gather information on the environment in which training exercises will be run.
I see. Well, that's probably what they're referring to. Conversation with Dick indicated, it was a little bit more formalized than your information.
Data must be collected, analyzed, and correlated with other known facts to form an accurate picture of the situation, which will be current when the exercises will be conducted.
Yeah, they should have the answer right there. Right. Well, that's a good...
Gathering simulation data requires people who are experts in their fields, such as this ex-Naval Combat Patrol Plane commander. He has had first-hand experience with the characteristics of military aircraft.
Let's call this an angled bank.
A complete picture of the environment for system training program exercises includes the results of surveys of air traffic, which will affect the air defense installation being trained. Also, accurate data must be recorded for the various boundaries, both civilian and military, which may affect the identification and flight paths of aircraft. And thus, the work of gathering and recording of background information continues to provide a fund of knowledge for the production of realistic training exercises. With such a background, the actual work on system training exercises can now begin, as the work of many people is coordinated in a tight production schedule. Meetings are held with Air Force officers who outline the training needs for which exercises will be produced. These meetings bring together System Development Corporation field representatives, simulation data people with their background of environmental information, formulators who will help plan the problem, and military personnel, the ultimate users of the training programs, who specify to System Development Corporation representatives the overall training goals which should be met, and agreement is reached on how these goals will be accomplished. The formulators must now take the basic plans and begin to conceive the problem.
These subs coming up and through here in the early part of the hour, it'll take care of the 26th until the main oceanic attack can come in. When they get just within the DC tide coverage, they'll launch their ASMs. This is just inside and just outside. So the full first hour is taken up with your high-speed aircraft, your sub-launched missiles.
These missiles are only hitting the coastal targets, is that right?
That's right. These will hit the coastal targets here.
The general outlines of a training problem, as prepared by the formulators, may be compared to an architect's sketch. Now that sketch must be taken to the problem designers, who make them into working blueprints, so the problem is explained to the designers by the formulator.
Actually, what the military will see will be a complete and unified problem. The only thing that they will not see will not affect them. That is, the octal correctors that are put in the initial conditions deck will change the entire configuration, the boundary configuration, and not necessarily reflect that on the tracks. Now, this particular area right out here with the AEW coming on, I think we can see it better from the map here. These locations out here on the AEW, these things are first going to be picked up by the AEW or the picket vessel, depending on what station they are at the time.
Problem designers must now begin the task of producing the detailed working documents.
Yes, here's the threat warning.
Designers and their technicians take the general system stresses, in this case air raids, and translate them into specific flights.
Get over here and we'll see what we got. This will be the threat during the first hour. There are 3 configurations in the problem, but this will be the first raid. We'll come in.
Drawing up the detailed computer manuscripts must be done for each individual aircraft flight, noting its specific speed, altitude, course, turn points, and many more specifications to make the flight conform to reality.
This one's coming in at 500 knots, this one at 480 knots, and they're at 14,000. And according to my estimation, they'll cross about here.
Fine.
Preparing manuscripts for processing by the computer involves checking of thousands of items.
So it's J. Howell, 3313.
Jim, I need the number of aircraft for SRN 543. Call-in time for initial report is 1604.
That's 4 aircraft on it. Repeat report.
Not all of the training aids are produced by the computer. Some non-programmed aids must be scripted by system training specialists. These inputs may enter the system to be trained as telephone messages read by simulation personnel from prepared scripts supplied in training packages.
096, track designator, King Delta 278. Altitude, 390.
More and more of this work is being automated. From punched card inputs, map coordinates can be read into a mapper plotter, which then actually draws flights on a map from point to point, replacing the time-consuming hand method used by cartographers. Training a system which extends over the whole of the North American continent involves recording the exact locations of thousands of geographical points. A machine has been developed for the System Development Corporation to reduce the man-hours of work formerly required for this tedious job. The large area record reader is an electronic device which can read maps. The operator indicates a certain location on the map, such as the point where a flight crosses an air defense boundary, and the machine automatically measures the coordinates to the nearest thousandth of an inch on the map, and either types them on an electric typewriter as a printout, or records the location of the point on punched cards. When all the planning and coordinating and writing are done, the system training exercise is in the form of a stack of manuscripts, ready for processing by a high-speed digital computer, which is used as an online production tool. The computer manuscripts enter the computer by way of a data flow room, in which each document is given a number and logged in to meet a production deadline. And thus, a system training exercise begins its trip through the computer phase of the production process. One of the first requirements is to make sure that the manuscripts are in the proper form to enter the computer, that all aircraft flights and other data are specified in language the computer can accept, and with the acceptance of the manuscripts, machine production begins. Because a digital computer is used, raw data must be converted to digits or individual holes on punched cards. The key punch machine operates something like a typewriter, with the operator transcribing information from computer manuscripts on a keyboard, causing sequences of holes to be punched in the proper places on the standard IBM cards. In order to prevent costly mistakes, punched cards are verified by a card reader, which enables another operator to compare the cards with the original manuscript. Before the information on the cards can be fed into the computer, the cards must be sorted according to their destination and the kinds of operations which are going to be performed. As a check on the sorting, the cards are collated, and every card is in its proper place. Pre-recorded magnetic tapes, stored in a tape library, are used in addition to the punched cards to produce training exercises. Information on a tape may be concerned with fixed data such as the location of radar sites, or the tape may contain the computer program routines which actually process the data. All these are fed into the computer's memory. The high-speed digital computer is a multi-purpose instrument. When it finishes work on one job, it is set up to begin producing a system training exercise. Its controls are reset, and all circuits and memory banks are ready to begin processing the data which has been fed in. The actual computations are over in a matter of minutes, and then the results are recorded on magnetic tapes, and from the tapes to punched cards, ending up with literally thousands of punched cards as well as a new set of magnetic tapes. A translation machine must convert from one computer language to another in order to enable the output of the production computer to be accepted by the military computer in the field, resulting in a problem input tape which contains the synthetic flights which will stress a section of the Air Defense Command. Another way of presenting stimulus inputs to the system being trained is by photographing the simulated aircraft flights on 70mm motion picture film, which, when run through a special device at radar sites, will electronically simulate realistic aircraft blips on radar scopes. Magnetic tape produced by the computer contains the data on specific flights, which now will be photographed on film. Special equipment has been designed to make the transfer from magnetic tape to photographic film. This specialized electronic equipment was designed by System Development Corporation engineers, and most of it was built in SDC laboratories. The film produced by this equipment can simulate aircraft flights, supplementing magnetic tape inputs, and it can also simulate electronic jamming for training purposes. In order to observe how a simulated air raid will look before it is photographed, it is possible to play the magnetic tape and examine the patterns of flight on a cathode ray tube. A 2-hour air attack played from a magnetic tape can be speeded up and checked in 40 seconds. Hostile raids head for their targets. Break formation. Rendezvous with other aircraft. Such might be the picture an operator sees on his radar scope during the exercise at his northern outpost in Alaska. When the 70-millimeter film has been exposed to the cathode ray tube picture, it is processed in a modified motion picture film developing machine. The process is continuous and automatic. Thus, from punched cards to magnetic film to spots of light on photographic film, the simulated air attacks move through the production process. The light transmission through sampled spots on the film representing blips of aircraft are checked with a microscope to ensure that the end result on a radar scope will appear realistic to Air Force crews. In addition, the relative location of sampled spots on the film must be checked to make sure that they are in the proper place at the proper time, as specified by the problem designers. At the same time, the punched cards also provide material for other training aids, such as teletype tapes, carrying reports of enemy planes penetrating the outer boundaries. Reports which will appear to have been teletyped from early warning stations. Other IBM electric accounting machines are modified to process still more system training materials. The computer has produced the cards, and now accounting machinery will be used not to process payrolls or update credit balances, but to perform as system production tools. Data on cards is converted into symbols on pre-printed maps. Other cards are used to produce reference lists of crucial facts and figures. Constantly recurring information is fed in by punched paper control loops, such as on the machine which prints system training programs simulated SAC strike routes. Multiple copies are automatically separated and stacked in orderly piles in the bindery. And finally, the pages are bound into system training booklets, which are fast becoming familiar to airmen around the world. All production materials must pass a rigorous quality control series of inspections. It is in quality control that the final product is carefully examined to see that it contains the problem content as specified in the original computer manuscripts, as well as satisfying the intention of the problem designers. Although most of the checking and cross-checking is done automatically by the machines, still human judgment is called upon for the final inspection to ensure compatibility of materials and to preserve the integrity of the simulation. All the materials necessary for a complete system training exercise present an imposing picture as they enter the shipping room for a final check for distribution. And then each problem package is assembled for shipment to all parts of the Air Defense Command. 70-millimeter film, magnetic tape, and all the printed scripts and aids and lists and maps, all the materials necessary to provide a complete training exercise, packaged air aids to provide simulated air attacks for realistic training of air defense crews. Exercising this large man-machine organization requires a regular schedule of problems of increasing difficulty. And thus, the North American Air Defense Command utilizes the most advanced concepts in system technology, computer-oriented control systems, and simulated air attacks in its system training program to fashion a powerful weapon of defense. Experience gained in such a large-scale military application has implications for new uses of system technology. Among these uses are the current SDC projects assistant to the designing and programming of the Strategic Air Command Control System, the Corporate Study Project of Military Command Systems, operational assistance with a variety of systems, both military and non-military in character, and many research activities of importance to the advancement of the system sciences. Out of research and experiments such as these may come the major breakthroughs in man's ability to develop and control systems of increasing magnitude. And thus the technology of automated data processing contributes to man's attempt to bring order out of the unknown, extending the boundaries of human knowledge.